Pause the video, give this a go, where I want you to turn this code into its recursive counterpart. Okay, so in order to do this, you need to understand really what's going on with this code. What we want to do is we enter in a number, let's say 4, so n becomes 4. And we're simply going to perform an addition, or this sum, or this loop, that amount of times, which would be 4. But we're starting on 1, and we are going therefore to 5, because we're starting on 1, so doing plus 1 as well. So we're going to take I, which is 1, and add it to sum. So the first time it loops, it'll be 1. The second time, it's going to be sum equals sum plus I, which will give us sum being 1, I will be 2, which should give us 3 in our code. Then, the next time it loops, let me just move this out of the way, it's going to give, let's just calculate it, so we've got 3 in our sum, we are on 3 now, I think, so it's going to give us 6. The next time it loops, I is going to become 4, 4 plus 6 is 10. So we've now looped 4 times. 4 times, sum is 10, and that's going to be our result. So, how do we do this in recursion? That is the question. Well, let's just write out our function header. So that's going to be the same. The first thing we want to do is identify our base case, which is going to be pretty simple. We want to stop when we get to 1. So counting downwards in recursion. So if n equals 1, we're going to return 1. That's our base case. Otherwise, we're going to do a return, and it's going to be n plus sum of numbers, and in here it's going to be n minus 1. So if we enter in 4, that'll be 4 here. It's then going to do 4 plus sum of numbers n minus 1, which will make it 3. Etc, etc, etc. Eventually, when it finishes and it unwinds, it'll give us 10. Feel free to trace it through in Python yourself. Okay. So if you're comfortable with winding and unwinding, you would understand that when we're looking at something like this, and it's saying to us value is minus 10, and that we're using then minus 10 multiplied by a count. Minus 10 is our first value that we're multiplying by. So if we're going to do this in recursion, I'm hoping you can investigate yourself first. Function, calculate. I'm not going to do the data type, I'm just going to do number. Great. The first thing we want to do is our base case. And our base case is when we get to, in essence, so when we get to 1, we want it to stop. So I'm going to do if number equals, I'm going to do it as Python 1, then calculate equals minus 10, because that's going to be our first value we're going to be using in our calculations when we unwind. That's what we're going to start off with. Else, and then let's do it. Calculate equals number multiplied by, let's do this asterisk, calculate number minus 1 to get to our base case. So if we were to put in, let's keep it really simple. I did not mean to delete that. The number 2. So we've got 2. We've got value equals minus 10. From 1 to 2, it's going to do value equals minus 10 multiplied by 2. Why did I do 20? Multiplied by 2 equals minus 20. It'll then do it'll be multiplied by 1 first, so it'll be minus 10 still. Second time it loops, it's going to do minus 10 multiplied by 2 equals minus 20. If we do this as a stack with our winding and unwinding, so if we're going to do like a trace table to show the winding and unwinding effect, I need to put in calculate. I'm going to pass in 2 to begin with. No result to this, but we're going to, so there's no return value. But what we are going to do is it's going to now call recursive 1, because it's going to be number minus 1. So wind, calculate 1, and now that we're at 1, we're going to have minus 10 as our return value. We're at the base case, and now we're going to unwind. Calculate 2, which is going to take on minus 10, multiplied by R2, which will give us negative 20. Done. Pause the video, give us a question and go yourself first. Okay, so let's turn this into its recursive counterpart. I'm going to do def factorial number. That's going to be our base case. So if number is equal to 1, it could also be less than 1 as we're dealing with factorial. We want to return 1. So that's going to be our base case. We know it's going to be less than or equal to 1 because we're starting on a loop, starting on 1 or 0 depending. Our base case is going to be 1 when we get there eventually. Else return number multiplied by factorial number minus 1. And there we go. Keep in mind that the number minus 1 is our loop to count down towards our situation. And here it's the same as basically doing this. Pause the video, give this a go yourself first. Okay, so excuse me, we've got a binary search going on here using iteration. We're searching for number 11, so it should return position 1, 2, 3, 4, 5. We run it. Yeah. Turn it into its recursive alternative. Okay, so I'm going to do it here. We want the array, we want the target, but I'm also going to take in low and high. As my parameters. And we're going to be basically saying if high is greater than or equal to low, mid equals high plus low, div 2. Because we're going to be now doing this, if the array mid equals our target, return mid. If our array mid is greater than target, return binary search recursive array, our target, our low, our mid minus 1. Elif, actually we can just do else. I'm going to do this again for the other alternative, but it's not going to be mid minus 1. It's going to be mid plus 1. And that's going to be for low. Get past high, too high. Otherwise, return minus 1. So let's just, we're going to call it, we're going to pass in the array, we're looking for 11, we're starting on 0 being our low, our high is going to be the length of the array minus 1 because we're starting on 0, and we'll print the results. So we had 5 last time, and it should be 5 again. There you go. How's this different to the iterative? Well, obviously we're not using the while loop. Everything else is very similar. We check and see if high is bigger than or equal to low, which it will be. High will be higher. So therefore, we're going to do this code. See what would happen if you really are that interested in changing this around to match the criteria of this. Understand why we're doing high, it's more than or equal to low, rather than whilst low is lower than or equal to high.